Lesson is lesson 7 for year 13 physics, and it's about standing waves in strings and pipes. So, a standing wave is produced in strings and pipes when the incident and reflected waves travel through each other. Strings, pipes, and other musical instruments have restrictions, which means it depends on the length whether the ends are open or closed. The waves that resonate to form standing waves are the ones that fit the restrictions of the string or pipe. Nodes are formed at closed ends as the medium is not free to move and the incident wave goes through a 180-degree phase reversal on reflection. So you've got to say both these things, not free to move and about the 180-degree phase reversal on reflection. Antinodes are formed at free ends as waves do not undergo a phase change, and so reinforce each other to form an antinode. I left out the word phase reversal, so I'll just add that in now. Okay, now transverse standing waves are formed on strings, and this is what it looks like when you have transverse waves on strings. So you've got one wave going there and the reflected wave coming back, and they go through each other. Now longitudinal waves are formed due to the vibration of air columns. So wind instruments actually have air vibrating in them. So the open ends will always have an antinode. How can you show it's an antinode? By showing the vibration is a maximum, and then in the middle you will have your node halfway between the antinodes, and the vibration is not as prominent in the other bits. The way that we can represent a longitudinal wave is like a transverse wave, so that's how you represent a transverse wave. Now, wavelength of standing waves, so that is a one wave. So a wavelength is from here to here, and so in one wavelength you've got 2 lots of antinodes and 3 lots of nodes in this particular one. Half a wavelength is just 1/2, and it can be this way, or you can, and this is a quarter wavelength, so which is kind of half of that. But if you've got 2 quarters back to back, you actually have a half wavelength here as well. The wave equation still holds good. Now let's look at, so this was just the introduction to standing waves in strings and pipes. The next lesson I will elaborate more, otherwise it's going to become